Hello friends, this is Rashmi Singh and welcome to my channel Unraveling Science. Solutions for Motion, Class 9, Chapter 8, Part 1. Questions from the chapter. An object has moved through a distance. Can it have a zero displacement? If yes, support your answer with an example. Yes, if an object has moved through a distance, it can have zero displacement because displacement of an object is actual change in its position when it moves from one position to the other. So if an object travels from point A to B and then return back to A again, the total displacement is zero. Second, a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes and 20 seconds? So the distance covered by the farmer in 40 seconds is equals to perimeter of the square field, which is 4 into 10, that is 40 meters. So the speed of the farmer will be distance upon time. That will be 40 meters upon 40 seconds, which is equals to 1 meter per second. Total time given to calculate the magnitude of the displacement of farmer is 2 minutes and 20 seconds, which is equals to 140 seconds. Now since in 40 seconds farmer completes one round, so in 140 seconds he will complete 140 upon 40, that will be 3.5 rounds. Thus after 3.5 rounds farmer will be at point C, therefore the displacement of the farmer will be AC, as you can see here. From Pythagoras theorem, displacement AC is equals to under root 10 meters plus 10 meters both the sides, which is equals to under root 200, that will be 100 root 2 meter. Now if we put the value of root 2 1.414 here, so we'll get displacement AC will be 14.14 meter. That's our answer. Third, which of the following is true for displacement? A, it cannot be zero. B, its magnitude is greater than the distance travelled by the object. None of the statements is true for displacement. First statement is false because displacement can be zero if the final and initial positions of the object are the same. And second statement is also false because displacement is always less than or equal to distance travelled by the object. Distinguish between speed and velocity. So the difference between speed and velocity is speed is the distance travelled by an object in a given interval of time. That is, speed is equals to distance upon time. Velocity is the displacement of an object in a given interval of time. That is, velocity is equals to displacement upon time. Second, speed is the scalar quantity, that is, it has only magnitude. Velocity is a vector quantity, it has both magnitude and direction. Speed is always positive, whereas velocity can be positive, negative, or zero. Under what condition is the magnitude of average velocity of an object equals to its average speed? As we know, average speed is equals to total distance upon total time taken, and average velocity is the displacement upon the total time. So, if the total distance covered by an object is same as its displacement, then its average speed will be equal to average velocity. This happens when an object is moving in a straight line. What does the odometer of an automobile measure? The odometer of an automobile measures the distance covered by the automobile. What does the path of an object look like when it is in the uniform motion? The object having uniform motion has a straight line path. During an experiment, a signal from spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? The signal travels at the speed of light, which is 3 into 10 to the power 8 meter per second. Now given is speed 3 into 10 to the power 8 meter per second. Time is 5 minutes, which is equals to 300 seconds. So the distance will be speed upon time. Putting the values, we will get distance is equals to 9 into 10 to the power 10 meters. When will you say a body is in uniform acceleration or non-uniform acceleration? A body is said to be in uniform acceleration if it travels in a straight line and its velocity increases or decreases by equal amount in equal interval of time. B. A body is said to be in normal non-uniform acceleration if the rate of change of its velocity is not constant. 10th, a bus decreases its speeds from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. So the initial speed of the bus is u is equals to 80. Converting it into meter per second, we get 22.22 meter per second. The final speed of the bus is 60 km per hour, which is equals to 16.66 meter per second. Time here is 5 seconds. So acceleration we know is change in speed upon time. That is v minus u upon t. Putting the values, we will get acceleration is equals to minus 1.112 meter per second square. 11th, a train starting from a railway station and moving with a uniform acceleration attains a speed of 40 km per hour in 10 minutes. Find its acceleration. So the initial velocity of train is 0. Final velocity of the train v is 40 km per hour, which is equals to 11.11 meter per second. Time taken here is 10 minutes, which is equals to 600 seconds. So acceleration v minus u upon t, putting the values, we will get acceleration is equals to 0.0185 meter per second square. 12th, what is the nature of the distance time graph for a uniform and non-uniform motion of an object? So when the motion is uniform, the distance time graph is a straight line with the slope, as you can see here in the picture. Similarly, when the motion is non-uniform, the distance time graph is not a straight line. It can be any curve, as shown here. 13. What can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? A straight line parallel to x-axis in distance time graph indicates that the change in time, with change in time there is no change in the position of the object, thus object is at rest. What can you say about the motion of an object if its speed time graph is a straight line parallel to time axis, as shown here? So a simple line parallel to time axis in speed time graph indicates that with change in time there is no change in the speed of the object. Thus the object is in uniform motion. What is the quantity which is measured by the area occupied below the velocity time graph? As you can see here, the area below the velocity time graph gives the distance covered by the object. We know distance is equals to speed or velocity upon time. A bus starting from rest moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. Find speed acquired and the distance traveled. So the speed of the initial speed is 0. Acceleration given here is 0.1 meter per second square and the time is 2 minutes, which is equals to 120 seconds. So we know that v is equals to u plus at. Putting all the values here, we will get final speed is 12 meter per second. This is the speed acquired by the bus. Secondly, according to the third equation of motion, v square is equals to u square plus 2as, where s is the distance covered by the bus. So putting the values, we get s is equals to 720 meter, which is the distance traveled by the bus. A train is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. So the initial speed of the train is 90 km per hour, that is 25 meter per second. Final speed of the train is 0 because the train finally comes to rest. Acceleration is minus 0.5 meter per second square. So now we know that v square is equals to u square plus 2as. Putting all the values in the formula, we get s is equals to 25 into 25 upon 2 into 0.5, that is 625 meters. This is our answer. A trolley, while going down an inclined plane, has an acceleration of 2 cm per second square. What will be velocity in 3 seconds after the start? So initial velocity of the trolley is 0. Acceleration is 2 cm per second square. Time is 3 seconds. So we know that final velocity is u plus at. Putting all the values, we get velocity of train after 3 seconds will be 6 cm per second square per second. A racing car has a uniform acceleration of 4 meter per second square. What distance will it cover in 10 seconds after the start? Initial velocity of the car is 0 meter per second. Acceleration is 4 meter per second square. Time here is 10 seconds. So we know that s is equals to ut plus half at square. Putting all the values in the equation, we will get s is equals to 200 meters. A stone is thrown in a vertically upward direction with a velocity of 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second square in the downwards direction, what will be the height attained by the stone and how much time it will take to reach there? Initial velocity here is 5 meter per second. Final velocity of a stone is 0. Stone comes to rest after reaching maximum height. Acceleration is in downward direction, so acceleration due to gravity is minus 10 meter per second square. Now we know that v square is equals to u square plus 2as. Therefore, height attained by the stone will be s is equals to u square minus v square minus u square upon 2a. Now putting all the values in this equation, we will get s is equals to minus 25 upon minus 20, that will be equal to 1.25 meters. This is the height attained by the stone. Now from the first equation of motion, v is equals to u plus at. So t will be v minus u upon a. Now putting the values again in this equation, we will get time is equals to 0.5 seconds. So the time taken by the stone to attain the height is 0.5 seconds. Thanks for watching. Please do like, share and subscribe.